All right, any questions with the first page? Yes.
The last one, did you put 35? Why did you put 35 as the grid under?
Because we have to make an adjustment with directional bearing. So that 35, north 55 east is not the true standard position. So we have to figure that out. So that means we're starting, the end means we're starting north, or we're going to move 55 degrees east. So so that means 55 east is really 90 minus 55, which is really standard position is 35.
Okay.
Okay. Good. Any other questions? First page. Okay. Page 28. Should be pretty straightforward. Number 8, you're just using that cosine formula to get to your get to the angle between them. Okay, anybody still need this page? Okay. So again, the formula tells us that we're going to find the dot product in the numerator, and the denominator, you're going to go through magnitude for both vector v and vector w. So go through Pythagorean theorem. And then to ensure that you're going to get the best approximation possible, leave this as one fractional value, do inverse cosine of this big mess, and that way you're not getting to a decimal value too early, which will kind of throw off your accuracy a bit. So. Okay, so very similar to what you were able to demonstrate on the quiz, just being able to use the formula to find the angle between two vectors. All right, so number 9. A batter on the opposing softball team hits a ground ball that rolls out to left field. The left fielder runs towards the ball at a velocity of 3 meters per second Cubes proceeds to throw to the catcher at a speed of 30 meters per second, an angle of 25 degrees with a horizontal. What's the resultant speed and direction of the throw? So this is a more of a straightforward problem where you have the two vectors and you're just going to add them together and get to the resultant. We don't have to do any rearranging. There's no subtracting of vectors. This is more straightforward here. So I'm going to say so I'll call this vector 1 plus vector 2 is equal to the resultant vector. Okay, and I'll let vector 1 be the run, the left fielder running, and then vector 2 is going to be throwing the ball. Okay, and then what's the resultant speed? So he's running towards the ball, but he throws it horizontal. So as he's running, he's going to be running the same direction that he's going to be eventually building that angle from. So we can consider it as that horizontal component is just that 3 meters per second is just in the straight line towards the ball. So a visual representation could be like this, where he's running at 3 meters per second, and then 25 degrees with the horizontal. This is where the throw is going to occur, and the resultant vector is going to be this last one here. So think of it as horizontal, and then the one that needs put into component form. Okay. Angle is 25 degrees. Okay. Add the components together, 3 plus 30 cosine 25, 0 plus 30 sine 25, and then we'll have our resultant vector. Okay. From here on out, should be pretty easy here. Resultant speed, Pythagorean theorem, direction, use inverse tangent. Okay, look at the sign of your vector. Looks like that's both positive, so we're just dealing with quadrant 1, which means that we don't have to adjust our theta value. Whatever we get for our theta is going to be the true direction. Okay, any questions with 9? Okay, number 10, a corporate jet is flying at a bearing of 320 degrees, 425 miles per hour. If a 40-mile-per-hour wind blows at a bearing of 209 degrees, find the bearing and speed that the pilot must use to maintain the jet's former course. So here, I know we see bearing, but look at how everything is in terms of bearing. So this is bearing. Both vectors are in terms of bearing. And then we also want to find the bearing at the very end as well. So here, just leave everything in terms of bearing. We don't have to do any adjustment, and it's just at the very end, we'll just call whatever degree that we have bearing. Okay, so there's no need to adjust because we don't have any change in, we don't have to match any of this information, right? All of this is already lined up perfectly for us, so just leave everything in terms of bearing, and that way we don't have to go back and forth. Okay, corporate jet is flying. Okay, 40-mile-per-hour wind blows, and then we're going to find the bearing that speed must use to maintain the jet's former course. So this basically is the resultant vector, okay? The jet, the pilot wants to maintain this course, so it's going to have to make an adjustment because once the wind blows, it's not going to be able to stay on this course anymore. So this is really the resultant vector here. Okay, but which means we have to do some adjustment, right? So plane vector plus wind vector is equal to the resultant vector. But since we have the resultant vector and the wind vector, we have to subtract it to get to, because the plane is going to have to point in a different direction to kind of counteract against that wind so that it can stay on course. Subtract, right? We got to subtract. R minus W, so we got to change these signs here, subtract them out. Okay, so this vector, from our perspective, is still sitting in the fourth quadrant, right? So we have to still add that 360, even though it is bearing, but we just have to do everything that we do normally, but then just in the end, we just leave it in terms of bearing. Go ahead. All right, any questions with 10? All right, 11. Feels a lot like the work problem, the physics problem that we did yesterday. 2 cables suspends the lighting system. Right, cable forms 140-degree angle with each other. The lighting system weighs 950 pounds. What is the force exerted by each of the cables on the lighting system? This 950 pounds is going to be balanced out from both sides there. So ultimately, we're trying to find the force exerted by the cable on the lighting system. So we're trying to find this vector, this hypotenuse, but we really need to focus on one of the triangles, right? So this 140 degrees is going to be helpful. Remember, everything is symmetrical. Everything is going to add up to 180 if it's along the horizontal. So what angle measures could be sitting in one of these triangles here?
20.
20, right? So 20 plus 140 plus 120 is 180. So we know there's symmetry here. This is 20, this is 20. But all we need is one of the triangles here. So I'm going to make that a little bit larger. So now it's just as easy as choosing between using one of sine, cosine, or tangent to solve for vector v. All right, so I'll use sine. Cross multiply, solve for vector v, or the magnitude of vector v. Yeah, question. Okay, any questions? Okay, so I'll come around and check off your 2 pages. Tomorrow we'll do the final 2 pages, and then your test is on Thursday. Okay, go ahead.